Hello, my name is Nurul Najihah Binti Azlan. I would like to present for assignment Data Communication and Networking. Our topic is Internet of Things Smart Health Kits Obstacle Vehicle. I would like to present our project to Dr. Azlishah bin Othman. And our group member is Teng, Cheah Chen, and me Nurul Najihah Binti Azlan.
Now, I will present about the introduction. Blindness is the lack smart vision caused due to physiological or neurological factor resulting in visual disability. Blindness can be temporary or permanent, and partial or complete blindness causing a person become dependent on others for help. Moreover, these individuals make numerous changes in their daily exercise, such as walking, socializing, reading, and driving. In this assignment, we will explore the feature and benefit of the IoT Smart Blind Stick, highlighting its potential to improve the life of visually impaired individuals. IoT Smart Blind Stick is an innovative device, which is an initiative to help blind people to resolve the problem faced by them in their daily life. Next, I will present about the problem statement. Visually impaired individuals face numerous challenges in their daily life, particularly in terms of mobility and safety. Traditional white can provide basic assistance but lack the ability to detect obstacles or provide real-time feedback. This limitation puts visually impaired individuals at a higher risk of accident and limit their independence. There is a need for an advanced solution that incorporates IoT capability to enhance the functionality of the blind stick, provide users with reliable obstacle detection, navigation assistance, and real-time feedback to improve their mobility and safety. Addressing this problem will greatly benefit visually impaired individuals, empowering them to navigate their surroundings with confidence and independence. Now, I will present about the objective. For this assignment, there are two objectives. First is to design an assistive technology for visually impaired people can detect obstacles easily. Next is to help blind people to work with complete relief and self-dependency.
Okay, this is our circuit design of the project. This figure shows the schematic diagram of the system. This is the ultrasonic sensor. This is not MCU ESP32, and this is piezo buzzer positive connected to GPIO 17, and the negative part is connected to the ground. Next, VCC ultrasonic sensor connected to VIN, the trigger connected to GPIO 26, echo is connected to GPIO 25, and ground connected to ground. The flowchart shows the sequence of programming coding. First, we start, then read the input data from ultrasonic sensor. Next, when distance less than 50 cm, piezo buzzer will turn on and synchronize with Blink IoT. And the system is end. For coding demonstration, this image shows a snippet of source code from an Arduino cache file called IoT Blink Stick. For a project involving a device called IoT Blink Stick, the code uses the Blink library for IoT project, allowing the device to connect to the Blink IoT platform. This code also includes a distance, threshold, authentication token for Blink, Wi-Fi credential, and variable declaration for storing ultrasonic pulse duration. Calculate the distance. First, define Blink print serial. Next, define Blink template ID and Blink template name, which is IoT Blink Stick. This is the dashboard template name for Blink IoT. Next, for include Wi-Fi. This is initiate Wi-Fi library for connectivity, and for Wi-Fi client, and next Blink simple ESP32. For define trick pin, ESP32 pin GPIO26 connected to ultrasonic sensor check pin. Next, define echo pin 25, ESP32 pin GPIO25 connected to ultrasonic sensor echo pin. For define buzzer pin 18, ESP32 pin GPIO17 connected to piezo buzzer pin. And for determine the distance, threshold 50 is centimeters. This is the authentic token for Blink IoT. Your Wi-Fi is credential and set password for open network. This is the name of Wi-Fi ID and this is the Wi-Fi password. For variable will change which float duration and distance in cm. The main loop of the code involves reading distance measurement from the sensor, calculating the distance based on the duration of the ultrasonic pulse, comparing the distance of predefined threshold, and controlling a buzzer based on the distance value. Additionally, the code prints the distance value to the serial monitor and set it to a virtual interface using the Blink library. In summary, the code snippet provided is implementation of an ultrasonic distance sensor system using C++. It includes the necessary function and commands to initialize the sensor, read distance measurement, compare them to a threshold, and control a buzzer based on the distance value. The Blink application was selected to interface our project to be implemented using Internet of Things. Before the system can be fully monitored and controlled using both website and mobile platform, there are several steps that was indeed a crucial part of building the IoT system, and to ensure that the original system can be linked with Blink platform and synchronize the output result to the IoT cloud. At first, an account had been created in Blink console website, then login verification required for further development. After the login process had been complete, a template must be created first before all relevant information can be stored. In this part, the type of hardware chosen in ESP32 and using Wi-Fi connection where the template name has IoT Blink stick. The next step after a template was created is to add data stream inside the template. Virtual pins are selected with different data type for our project component respectively. In this case, one virtual pin is selected as string data type to set as the output for the LCD display in Blink dashboard on showing the distance that is detected by ultrasonic sensor. Once all virtual pins have been declared, then need to select the button and label widget with selected virtual pin accordingly. This process can be done at web dashboard in Blink console platform. Lastly, for web Blink console, a device need to be created with different options. In our case, the device is selected based on the template that had been created earlier. After that, the device information will be shown, including the template ID, device name, and Blink authentication token for linking purpose in Arduino IDE software. For the mobile dashboard of Blink application, the template and device that has been created along with associated virtual pin information will be synchronized in smartphone when we log in using same account. Then the widget can be added accordingly by select suitable data stream. This figure shows the circuit setup for IoT Blink stick system. The setup of the IoT Blink stick system that made up of an ultrasonic sensor, node MCU, ESP32 microcontroller, a piezo buzzer placed on the breadboard. As the ESP32 represents a Wi-Fi and Bluetooth module, hence it requires a network for it to link with the cloud, and it is essential to ensure that the Wi-Fi are connected as same between controller and computer. The controller will recognize the IP address of the network for it to go online on the Blink platform. Link-related commands should be received to ensure that there is a communication between the controller and the IoT platform, or else we can monitor the output result through the widget inside the dashboard. This figure shows the Arduino IDE coding to be uploaded to the Node MCU ESP32 microcontroller, as it defines the different pin on ultrasonic sensor to the GPIO pin of the microcontroller, along with threshold distance declared. This figure shows the output result obtained in the serial monitor interface inside Arduino IDE software after the coding has been successfully uploaded to the Node MCU ESP32 microcontroller. Then, the result obtained inside the Arduino IDE software will be transferred and verified through Blink dashboard. This figure shows below the creating of a template along with types of microcontroller used to link the device. This figure shows the interface of the Blink dashboard after a device has been added from selected template, along with the widget added and declare the respective output pin that has been defined earlier inside the Arduino IDE coding. After the result in computer side, which are Arduino IDE software that responsible for serial monitor, and Blink dashboard, which responsible for creating a template ID to link the controller in IoT way. Next, a mobile application can also play in by just selecting the template that has been created in dashboard side and added respective widget with pin declared. We can then also monitor the result through mobile side. As from figure, live result observed from Blink dashboard and serial monitor interface in Arduino IDE software, it can be concluded that the output result obtained we both synchronize with each other but just differ in terms of decimal places. This figure shows the setup of Blink mobile application, and this is LCD display result which produced by the ultrasonic sensor, and the data is synchronized directly. From the result that monitor using Blink platform, which is a IoT platform that can be widely used due to its strong function, and it can be said that the Blink IoT system is successfully P32 in running. The program is set as 9600 baud, which can execute the program efficiently. The data of measure distance from the receiver circuit will be transferred directly to the Blink application to keep providing the update information to the user about the exact distance between user and obstacle, with the help of buzzer which will turn on when it runs below a certain threshold. From the above result, it is clearly shown that both mobile and web dashboard will synchronize to each other by logging to the same account and multiple widgets, and the LCD display is added to meet our design specification.
Now, I present about the conclusion. The IoT smart light stick emerges as a transformative force in the realm of assistive technology, symbolizing the fusion of innovation and empathy. In our exploration of this groundbreaking device, we have witnessed its capacity to rectify the landscape for individuals with visual impairment, offering not just enhanced mobility but a renewed sense of autonomy and confidence. The integration of IoT technology into the traditional white can signify a significant stride toward a more inclusive society that leverages advancement to break down the barrier and empower every individual, regardless of ability. That's all our presentation. Thank you.